Hi! We will present to you all about our project about smart home light. So let's take a look.
So, the first one is introduction. Smart Home Light Control is an IoT-based project that allows users to control home lighting remotely. The system uses ESP32 with built-in Wi-Fi to switch on light on/off using a smartphone. Users can control the lights through a mobile application Blink from anywhere with internet access. This project improves convenience, safety, and energy efficiency in daily life. It provides a simple, low-cost, and user-friendly smart lighting solution. These projects help students understand integration of hardware, software, and wireless communication.
Next is objective. For this project, we have several objectives that we would like to achieve. First off, to develop a smart lighting system using a microcontroller, which is ESP32, through wireless communication technology. Second, to establish Wi-Fi-based connection between the smart lighting hardware and the mobile application. Third, providing a mobile application interface where allow users to remotely turn the light on and off. Fourth one, to test the system functionality and reliability when using a smartphone to control the light. Lastly, to demonstrate how smart home technology can enhance consumer comfort, energy efficiency, and convenience.
I would like to present about digital collaboration and the tools we use in our project, which are WhatsApp, Arduino IDE, and YouTube. First, WhatsApp was used in our main communication platform. Through WhatsApp, group members were able to discuss project ideas, share information, and update progress quickly. It also helped us to solve problems faster by sharing pictures, videos, and messages in real time. Next, Arduino IDE played an important role in our collaboration during recording process. It was used to write, edit, test and debug the program for ESP32 microcontroller. Team members share code, discuss errors, and improve the program together to ensure the system work properly. Lastly, YouTube was used as a learning and reference platform. We watched tutorial videos to understand ESP32 programming, Blink application setup, and circuit connection. YouTube helped us gain a clearer understanding and guided us step by step during development. In conclusion, these digital collaboration tools help our team communicate effectively, learn efficiently, and complete the project successfully. Without this platform, teamwork and problem solving would have been more challenging.
For the approaches and techniques, our project focused on using IoT technology to enable remote light control. First, the ESP32 connects to Wi-Fi using its built-in wireless capability. This allows the system to communicate with the internet. Next, we use the Blink mobile application as the user interface. Through the app, user can control the light by simply pressing a button on their smartphone. The ESP32 is connected to a relay module, which acts as a switch to safely control the light circuit without direct high voltage connection. When the user presses the on or off button in the Blink app, the command is sent through the internet to the ESP32, and the relay will turn the light on or off accordingly. Finally, we tested the system multiple times from different locations to ensure stable connectivity, fast response, and reliable operation.
This slide shows our organizational chart. I am ANIQ, the project manager for this project. My role is to plan the project, divide tasks among team members, communicate with the team, and monitor the project progress to ensure everything is complete properly and on time. Next, RUSSAIREEN is our electrical engineer. She is responsible for handling electrical components, wiring, and circuit connection to ensure safe and proper operation. AZRUL FAHRIN is the software engineer. He is in charge of programming the ESP32 and integrating the system with the mobile application. Lastly, NURSYAHMINA is the designer engineer. She handles the system design, layout, and prepares the presentation and documentation materials. Together, we will as a team to ensure the success for this project. Project manager responsibility. The project manager is responsible for planning the project and dividing tasks among team members. They communicate with the team to discuss project process and solve any issues. The project manager also checks the progress regularly to ensure the project stays on track. Finally, they make sure the project is complete properly and on time.
Next is software engineer. Software engineer need to design and develop system software architecture. They also need to use Wi-Fi to connect and control communication between hardware and mobile app. Software engineer also need to write, test and debug code to ensure system works properly. And last, to record coding steps and software architecture for reporting.
For my part as the designer engineer, I selected suitable hardware components such as the ESP32, relay and power supply. These components were chosen because they are cost-effective, safe to use and suitable for IoT application. Next, I was involved in designing the overall system, which integrates both hardware and software. This includes connecting the ESP32 to the light circuit and ensuring it can be controlled remotely using a smartphone. I also tested the prototype to make sure the system works properly, responds correctly to user commands, and operates safely. During development, I analyzed and solved technical issues such as connection problems or delays in response to improve system performance.
Next is electrical engineer. Electrical engineer, they troubleshoot and repair electrical system faults. They prepare technical drawings, wiring diagrams and documentation. They prepare specification, electrical equipment and materials. They perform engineering tasks using CAD or engineering software and tools.
For the project timeline, our work starts on 21st November 2025. At the beginning, we discussed the project requirement and objective. And then we decide to develop a smart home light control system. Then, we researched and selected the required components, finalized the list and complete the purchasing process. After receiving the component, we inspect the quality and start working on the hardware circuit design and software programming simultaneously. Throughout the development phase, we continuously tested and improved the system to ensure proper integration between hardware and software. Finally, in January 2026, we focused on system testing, debugging, and final improvement.
This slide shows the main components used in our project. The first component is ESP32, which acts as the main controller and handles Wi-Fi communication. Next, we use a breadboard to build and test the circuit without permanent soldering. Jumper wires are used to connect the components on the breadboard. Then, we use LED light as an output device to represent lighting system in our project. In addition, we also use a resistor which helps to limit the current and protect the LED from damage. A power bank is used as the power supply to provide portable and stable power to the ESP32. Lastly, the Type-C cable is used to connect the ESP32 to the power source and for uploading the program during development. So, this slide shows our coding at Arduino IDE apps. This is our project before decoration. And this is our project after decoration. As you can see here, this is our result, but before turning on the button through phone app. After turning on the button through phone app, this is our result. You can see the LED light is turning on using phone.
Last but not least, conclusion and recommendation. The project successfully developed a smart house lighting system controlled through a mobile application. User can remotely switch lights on and off through a wireless IoT connection. The system integrates hardware, software, and mobile application effectively. This showed the application of IoT technology in daily life and improved user convenience and supports energy efficiency. From this project, we also provide a foundation for future smart home automation system, where we would like to suggest for future enhancement may include time scheduling and brightness control features. And not to forget, we would like to thanks to our lecturer, Ms. MUSFIRA Muhammad AZMIR, for guidance and continuous support along the journey for this project.
Thank you from us. Bye.